For example 1, I'm going to start by drawing a quick sketch of the function. You don't need to, but I'm going to draw it just to make sure I know what's going on. So the graph of sine 2x is going to be a stretch of the sine x graph by scale factor of half, parallel to the x-axis. So it's going to look something like this. And we know that it's going to cross the x-axis at pi over 2. So in this question, we're rotating this region between 0 and pi over 2 around the x-axis. So we just need to remember our formula for the volume of the solid created when we do that. Around the x-axis, it's integral of pi y squared dx. And we should put in our limits at this point. We're integrating from x equals 0 up to x equals pi over 2. So next we just need to sub in what y is equal to. I'm going to take pi outside of the integral, and y squared is going to be sine squared 2x dx. Now, sine squared is a really common function that you need to be able to integrate in further maths. And to integrate sine squared, you need to remember the identity. Sine squared theta is a half 1 minus cos 2 theta. The equivalent identity for if you needed to integrate cos squared would be cos squared theta is a half 1 plus cos 2 theta. And both of these can be derived pretty easily from the double angle formula for cos 2 theta. So in this case, we want to integrate sine squared 2x. So let's replace theta in this identity with 2x. So we're going to get an expression for sine squared 2x, which is a half 1 minus cos. If we replace theta with 2x, we're going to have 4 theta there. 4x, sorry. So let's replace sine squared 2x with that expression there. And you don't need to, but I'm going to take the half outside of the integral at this point. So we're going to have pi over 2 integral of 1 minus cos 4x dx. So integrating 1 is simple, that's just going to integrate to x. Let's go through how to integrate cos 4x. So I'm going to split this up. Obviously you wouldn't write this, but just to show you what I'm doing, I'm splitting this up into integral of 1 dx minus the integral of cos 4x dx. So you might just be able to do this without doing a substitution, but if you weren't sure how to integrate that and you'd forgotten the trick, you could just use a substitution. So the substitution that you would use is you would say u is equal to 4x, so that du by dx is equal to 4. Now if we're doing a substitution, we want to replace dx with du. So if we rearrange this to get dx on its own, we'd get a quarter du. So this integral would be cos u times by a quarter du. So we'd have a quarter, and if we integrate cos with respect to u, you get sine u. And obviously u is equal to 4x, so we're going to get a quarter sine of 4x. So if we go back to our integral, we're going to have pi over 2, and then when we integrate each of these, integrate 1, and we're going to get x minus the integral of cos 4x, which we found to be a quarter sine 4x. And we're going to have to sub in the limits of pi over 2 and 0. Now with this integral here, you wouldn't do a substitution in further maths because you are going to do so many of these every single exam that you just want to be able to recognize how to do this. So the trick is, if you've got a multiple of x or a linear function of x inside another function, so here we've got 4x inside the function cos, you're going to divide by the derivative of the inside function. Now that trick only works when you've got a linear function. So for example, if you had the integral of e to the 5x dx, Well, if you add e to the u with respect to u, it would integrate to e to the u. So that's going to integrate to e to the 5x. But we need to divide by the derivative of 5x, which is a fifth. Or another example, if we had the integral of sec squared 3x plus 2. Here we've got a linear function inside another function. So we're going to integrate sec squared. Sec squared integrates to tan. And then we divide by the derivative of the inside function, which is a third, times by a third. So finally for this question, all we've got to do is sub in the top limit and the bottom limit. So if we sub in the top limit, we're going to have pi over 2 minus a quarter sine of 4 times pi over 2, which is 2 pi, and subtract, what do we get when we sub in 0? Well, we're just going to get 0. So sine of pi over 2 is 0, so we're just going to end up with pi squared over 4 if we multiply that out.